Alright, hi everyone, my name's Amy and today we're going to be doing a workshop on Introduction to Computer Vision and OpenCV. So basically, in a nutshell, what computer vision is a machine demonstrating like what we see, but a machine doing it. So how does OpenCV help with that? It's basically a giant library to make that possible, to make it really simple. So some applications of computer vision that you guys might be familiar with are facial recognition, like if you have an iPhone 10 and you swipe up, it automatically opens because it detects your face. Some object detection, self-driving cars, and smart home devices. So instead of me talking about what computer vision is, I thought it'd be kind of fun to do a Kahoot. So if you guys want to get into teams of like 4 people, 4, maybe 5 people. Yeah, so that was basically a little introduction to what OpenCV is, some computer vision stuff. There's a lot of algorithms in the OpenCV library, and they're all optimized, to do whatever you really want to do. So we're going to do a really basic workshop today on, basically we're going to be given a picture and we're going to circle something out of that picture. So first thing we're going to want to do is go into this tiny URL and then, Okay, so go into this tiny URL and then go ahead and download the Colab notebook. If you guys aren't familiar with Google Colab, there are mentors to help you guys out if you need it. So just raise your hand and they'll come and help you out. If you are familiar with Colab, just upload it into Colab like you would usually do. So whenever you get everything working, you should see something like this, and then up in the corner, you guys just want to make sure you want to click connect. Because then that'll get everything going. All right. So is everyone doing okay? Okay. Cool. Okay. So basically what we're going to do today is that we're going to be given a picture of strawberries, and then we're going to want to circle the strawberry and hopefully circle the biggest strawberry out of the bunch of strawberries. So the first thing you're going to have to do is Google a picture of strawberries. So a picture it could work well with is something like this. So what you're going to want to do is you're going to want to save that picture anywhere you want, really. Let's just call it strawberries. Just remember where you save it. And then once you get that picture, what you're going to want to do is click this little arrow. You're going to want to click on Files, and then Upload. And then you just want to upload the picture of strawberries that you downloaded from Google. And don't worry about the little error message. Okay? And if anyone needs help, please just feel free to raise your hand. Okay, so basically all the stuff up here is just some libraries that we're going to need to do this workshop. And then we have some helper functions. Basically all show is going to do is anytime we call show, it's just going to show us what we've done to the image that we uploaded, which is the strawberries. We'll talk about show mask and overlay mask later. So the first thing that we're going to have to do is we're going to want to read in the image. So we're going to say image equals, so from Computer Vision 2, which is OpenCV, you're going to want to read it in. And then whatever you called the image that you saved, so over here I called it strawberries.jpg, so we're going to want to call it, that's what we're going to want to pass in. Okay. So to show you how show works, I'm just going to pass it in. So you're going to see this. Okay, everyone doing okay so far? All right. And then if you want to get the dimensions of your image, all you're going to have to do is just call image.shape. And whenever you run that, you're going to get the dimensions. So it's going to give you the height, the width, and the number of channels. So in this case, for me, it was 496 by 700 and 3 channels. And channels basically represents the number of components used to represent each pixel. Don't worry too much about it, but yeah, image.shape is just how you get the dimensions of the image. Okay, so another thing OpenCV is CVT color. So basically all it does is convert from one color space to another. So as in you're going from BGR to RGB. So to show you what that does, just type in show image and then you'll see what happens. So basically instead of this blue looking picture you get up here, you're going to get like a regular picture because you converted it. And then this is just going to resize it so that it's easier to pass into later functions. So yeah, so basically when you resize the image, it just made it a little bit blurrier because it is making it a smaller file. Okay, so the next thing that we're going to do is we're going to blur the image. So we're going to be applying something called a Gaussian blur. And what that does is it blurs it out to reduce noise in the picture so that whenever it's trying to detect the object, it makes it a little bit easier when there's less noise. So to do that, we're going to call it image blur. It is going to be CV2. Yeah. And then hopefully I don't mess up the spelling of it, but it's going to be Gaussian blur. You're going to want to pass in the image, and then you're going to pass in something called a kernel size. Don't worry too much about it. And then the standard deviation. Again, don't worry too much about it. Just know that the Gaussian blur, all it's doing is you're passing in an image, making it blurry so that it's easier for it to get detected. So to show you what that does, we're gonna click show and then just press play. And then you'll see that we blurred the image that we passed in. Okay, does anyone have any questions so far?
Can you scroll really quick to where you can find the dimensions?
As in the image blur?
No, cell number, I don't know, just after the help function. Yeah.
The image part?
Yes, sir.
Sure. Well, we have it in our presentation.
The IM method, is that from OpenCV?
Yeah. So anything after CV2 dot, that's going to be from the OpenCV library. So IMRead is just to help you pass the picture into, to pass the picture in that you want to filter out.
Okay, and then show image, is that also a method from?
Yeah. So show image was part of the helper methods. So up here, whenever you call show, anytime that you call show on the image, it's just going to show you exactly what you've done. So what we did was we just read the image in. So whenever OpenCV reads an image in, it reads it as like this weird blue looking thing. So before that we put the filter on, so we converted it from BGR to RGB. Whenever we showed the image afterwards, it looks like the normal picture that we downloaded off Google.
Can we ask you to press Command Control F?
Command Control F?
On your Google Chrome, yes. Control Command F.
Oh, okay.
And then maybe we can expand the code if you exit out of the file.
As in...
Well, if you just click X into the file, so you have more space to see the code. It's a little bit less distracting.
Wait, sorry, which
if
part?
you like.
Oh, sorry,
suggest.
Close cross.
Where it shows your data.
Yeah, the table of contents.
This is an X right by what it says.
Oh, okay. Sorry about that. Okay. Okay, so now that we blurred the image, so basically all this code over here is doing is it's telling you like what red is. So it sounds kind of weird, but it's basically like there's different hues of red. So all we're doing is we're taking, we're going to convert it to HSV, which basically means that it looks more kind of like what we're used to seeing versus what a computer sees, which is normally RGB. So HSV is like what we see, so we're just going to convert it to that so that whenever it is detecting an object, it's like as if we're seeing it. So we're telling the computer to do that, to like see what we see. So then we're going to have different hues. So all we're doing is we're going to have something called a NumPy array, and you're just determining the different shades of red. So as in for the 0 to 10 hue, which is again just different shades of red, the minimum red is going to be these specific numbers over here, and the maximum red is going to be these specific numbers over here. So to show you what it's doing, if you just uncomment show mouse, so for image red 1, and press play, you're going to see that basically this is what the computer is detecting as red, which is pretty accurate compared to what we had before. But there are some pieces missing. So that's why we have the second part over here, this image red 2, because what that is doing is it's detecting the missing parts of red that the computer didn't detect yet, because again, there's different shades of red. So if we uncomment this part again and see what's happening, you're going to see that it detected those remaining little spots that are red, which were in the original picture. And then the last part, all it's doing, so image red, all it's doing is just combining these two things together, and then it's giving you the final image. So I'm going to uncomment this again. So combined, it looks like that. So this is our final result that we're going to be passing in as we move on throughout the workshop. So to show you again what's happening. So this was image red 1, this was image red 2, and then we just put them together so that we don't have any missing spots. Alright. So next part of code, don't worry too much about it. It's just basically to help clean up the image. It's a little confusing, so just know that that's there to kind of help clean it up. It's just some OpenCV, some methods from OpenCV to help us out to clean everything up. So for the last part, we're going to want to find the biggest contour, and all a contour is, it's a curve joining all the continuous points that have the same color or intensity. So before we circle the strawberry in the image, we have to tell it like what do we want it to circle. So the first part of the code is that we're just copying the image over to prevent altering the original picture. So we're just going to copy it over. Then we're going to want to determine what the biggest contour is. So to do that, we have biggest contour is going to be the max of the contour sizes, which we defined up here. And then how we're going to determine the max is it's just going to be by So it's just going to be by the first thing in the tuple. And then we're going to want to get the first element out of that. So then this mask is just going to be a NumPy array of zeros. So after we have that, what we're going to want to do is from CV2, we're going to want to draw the contours. So the first thing you want to pass in is the mask, which is the source image that we want to pass in. Then we're going to pass in the biggest contour, and then whenever we use the draw contours function from CV2, we have to pass it in as a list. So then we have mask, biggest contour, and then we have the third argument is going to be the index of the contours. So we have -1, 255, -1. And then all we're going to want to do is just return the biggest contour in the mask. So whenever we do that, oh, sorry, hold on. Okay, yeah. So basically that's what's going to happen with the image. So now we've created the mask that we're going to put over our original image. That's basically going to determine what we're going to be circling. So is everyone doing okay? Alright. So now that we've found the biggest contour, what we're going to want to do is we're going to want to overlay the mask that we created on top of our original image. So to do that, we're going to use our helper function that we defined way up here. Or we didn't define it, but like I basically gave it to you guys and I told you we'd come back to it later. So we're just going to use this function to overlay the mask over our original image. So to do that, we're just going to call overlay mask. And then we're going to pass in the red mask, which was what we got right over here. We're going to pass that in, and then we're going to pass in our image. So when you press play, you're going to get that. So basically now the computer is saying, okay, here's a picture of strawberries. We're going to detect the strawberries out of it. And then, lastly, all this part of the code is doing down here is just drawing a circle around the strawberries. So if you just uncomment show and press play, we're going to see that that it works with another picture. Or sorry, not with another picture, but it works with the picture of strawberries. So this was just one picture. So like if we have another picture, for example, let's say, let's try this one. So if we put into Colab, and then we change this little part over here to strawberry 2. Then we see that out of this picture, it detected the biggest strawberry out of the picture. So, yeah. Do you guys have any questions?
What happens if you upload an image of a red apple?
It should work. I just use strawberries just because, yeah, they're good. But yeah, if you do like an apple, let's try this one, I guess. But yeah, since we set the parameters, it should work. So if we have just a little JPEG or whatever. So it works.
Do we consider this to be a successful model or a model that has some flaws?
It really depends. Like you can do OpenCV with neural networks and get really fancy and all that stuff. This was a really, really simple workshop. So it really depend on your definition of success, because it did accurately detect, the apple in the picture, and like out of the picture of strawberries, it did detect it. So yeah.
So there is a way to fine tune this to look specifically for strawberries instead of just red things, right?
There is, but you probably have to put more parameters in.
Yeah.
So because right now all of the parameters that we set were for red items that we gave it a specific range of what's considered red. So yeah.
So if we were to take one more counter example, like those Rothko paintings at the Museum of Modern Art, and they're just big blocks of color, like just a solid block of red. if you were to pass that into this model, would it still think that it's a strawberry?
I'm not entirely sure, but we can try it on like a solid red picture. So I guess just maybe try this picture. Are you talking about something like this or just like a block of red?
Sure. Or even the iPhone, for example. You have
This one?
a distinct object in
Mhm.
the red background. What will the model think? Will they think it's a strawberry? Is it going to circle the iPhone?
It's probably going to circle the iPhone, but we can see what happens. Oh.
What is this?
I guess probably got a little bit confused then. So it's probably not the best model out there. It can get very complicated very fast, so I wanted to make today's workshop more basic, just kind of give you a gentle introduction to OpenCV and some of the methods out of it and everything.
Just for the sake of discussion,
Mhm.
it looks like the models, would you say this is overfitting? It's circling like most of the image.
Yeah, probably.
What would it take to fine tune this model?
Probably give it stricter parameters or, probably stronger parameters because we gave it like a pretty wide range. We kind of just taught it to just detect red. So yeah. Alright, so it was a really short workshop, so that's about it for today.